Hi everyone, welcome to the through-hole version of the Carlson Ultra Probe, and I tried to make this just as ultra simple to build as possible. So right now, you'll notice one very interesting thing about the probe tip. It has an F connector on it. So it's a piece of Cablevision wire with an F connector. You can make different probe tips and, for different sensitivity levels. So the more center conductor you have exposed, the more sensitive this is to its surroundings. So if you had this cut exactly flush with the shield, you'd have to be very close to the component because it won't hear too much around it. I'll give lots of examples of this and the actual surface mount version once I have the actual detection unit and amplifier built. So right now, these are absolutely fine to run with just your standard signal tracer, and I'll even show modifications for a standard signal tracer as well in this particular series to show you how to use this with just any old signal tracer if you want to do that. Now again, the box that I'm going to build that goes with the probe will have many perks to it, so you're probably going to want to build that as well. So anyways, back to this thing here. So you see inside, it's nice and big. Now, first of all, you'll see a bunch of sockets here with transistors in them. You don't need to add the sockets. I've just put the sockets in here because this was the EXP or experimental version. That allows me to put different semiconductors in here and try different things out. So first of all, for these two transistors here in the front that basically act as protection for the FET, you can get away with in this model just using a 2N3904. All right, so you'll see the undetermined in the previous video, the documents there, which is the parts list. You'll see undetermined, so you can put 2N3904 in this particular build and it'll be absolutely fine. And pretty much all the rest of the parts in that parts list are the same. So you can see I built this with tantalums. You can use electrolytic caps if you want. I do prefer tantalums, so I put them in here. And all these resistors here are, I guess you could say, Amazon specials. So I ordered a bunch of resistor parts off of Amazon just to experiment with, and they work absolutely fine. So you can build this with junk box parts, and that's the whole idea, is to make this as simple as possible. It's very versatile, and you'll have very good luck with building this thing into the box like this, and just using pretty much anything out of your junk box. 0.1 microfarad capacitors, use what you've got in your junk box. You'll notice that the lead spacing is pretty far apart on everything here. I did that so it's somewhat universal, kind of a center, so if you have a part that's a bit bigger, you can kind of bend the legs in like this, or if the part's smaller, you can bend them out, like what I've done with the tantalum caps here. You see how the legs are bent apart. You'll notice the transistor legs are bent apart as well. And the reason that I've done that is so you can use different transistors in here. You can just experiment with this and have a lot of fun. That's the whole idea of this. Now, if you want to build this exactly the way that you see it here and what's using the parts in the parts list, you'll have results that are very close to the surface mount version. It's just, of course, because this is much bigger and it doesn't have the gain switch. There is no gain switch in this. I guess you could say the frequency response or the bandwidth will be a little bit different. And again, in the end, I'll go over all of that. Once I have both of these built with the amplifier unit and the detection unit, I will be using both of these in many videos. It's an incredible device and much, much more sensitive than the Super Probe. So you'll see that this would be absolutely fantastic for looking for noisy components and noisy vacuum tubes and everything. Just sniffing out signals and radios and test equipment would be great. I'm really looking forward to using this thing. I already have, and I know how incredibly fantastic this thing is already. So F connector here, standard Cablevision. The nice thing about these F connectors is these things here are just basically barrel connectors for F connectors. And what you do is you run a wire, just poke it into the end. It's not even soldered into here. And then, of course, you just have your regular wire plugged into this. And I did the same thing for the 369 antenna. Works absolutely fantastic. On this end is a BNC because the input to my signal tracers and the input to the detection unit and amplifier is going to have a BNC on it as well. So I've got a BNC on this end. So the F connector is nice. These things are so easy. If you get the an F connector stripper and then the crimp tool, these things go on this coax. I would say in 15 seconds you can put an end on a coax. They're just compression type connectors and they work great. Again, the 369 antenna has this exact connector on it, just a compression type connector, and it's been up on the 369 since it's been put together. No problems, works just fine. That 369 antenna is absolutely fantastic as well. So below this video you will find a component layout map. So this tells you where to put all of the components. All right, so this here is a little bit bright. I'll just lower that down just a little bit there. So this is below there, and you'll see here it says print on legal size paper. I would suggest that if you want to print it off, it makes it nice and big, and it's from end to end. All right, so that's an attachment below, and the actual PCB layout that's sized. So you just basically take this and put it on the copper side of the board and run it through the laminator. Of course, this is a laser print, right? And away you go. So if you're new to this and you're interested in learning how to do this, I have videos here on how to do the toner transfer method. Everything I do is the toner transfer method, and works just great. Laser sharp lines from the laser printer toner transfer. So now, a lot of things I can tell you here. You'll notice on the actual, I'll use this because it's it's big, it's that, but very, very large. By the way, when you're looking at this, you're actually looking down on this. So if you were to have this, like so, this way, you're actually looking down. So this is the components, just like this. So you're looking at the top side of this when you're populating it. Makes things a little bit easier. You'll notice that this is backwards, and of course, or mirrored, I should say. And the reason it's mirrored is because when you put this onto the circuit board, right, and it gets transferred on, right, if you see through it, right, that gets transferred on here. Some of the tricky stuff that happens when you build printed circuit boards. All right. So there you go. So you'll notice on this end, there's a bunch of pads here. It says in, and then I've got these two right here. If you want to run a fixed piece of coax, like the coax that I'm using in the surface mount version, you can basically take the shield and solder it, put a loop with a wire here through these two and solder it, and then solder the center conductor here if you want, if you don't want to do this. So you can see that I haven't drilled the holes here. There's the pad there and the pad there. I haven't drilled them because I've put it into this way. So you can do this in so many different ways. I've tried to make this as versatile for everybody here as absolutely possible. So, really large layout, really big parts. These are half-watt parts that I've used here, and they're all 1% resistors. Use carbon film resistors. Of course, you can't use wire wounds, but use carbon film or carbon composition resistors. Use whatever you've got in your junk box. It'll work. It's no problems. Very versatile unit. And as you can see here, so all the transistors here, and here, and then over here, just basically follows the whole thing. You'll see one big pad over here, and you can drill this out if you want to run a piece of fixed coax to this. Say you don't want to use a BNC here, and you want to run coax directly to this. You can solder the braid to this pad. That's why I made that pad so nice and large, and the center conductor can run here and then run out. Now keep in mind, there is no blocking cap here. All right, so whatever you're plugging this into, make sure that it's not going to pull this down, okay, because you're running right off the emitter here. So no blocking cap here. So if you need a blocking cap, add it in on the other end. Okay, so some of you may have experienced that. This is the input, positive and negative. You'll know, hey, look, negative goes nowhere except a circle. Well, how's that making connection? Well, you need to have a shielded box in order to do this. So the box has to be shielded. So it has to be a solid metal box. And of course, that will have to be on. Even if you turn this thing on your bench without this screwed down on top of here, it will hum like crazy because of the sensitivity of this thing. It'll pick up the lamps and everything around your bench. This thing is incredibly sensitive, and it needs to be capped. Now, you'll notice that this box that I've got is a weatherproof box, and you'll notice there's a rubber gasket around here. So if you lay this on top, it won't make connection. So you'll need to either have an alligator clip run to this if you want to, not screw it down if you're, experimenting with things. And if not, you'll have to put one screw in there or something just so that it makes contact with the bottom portion of the box. Okay. So again, if you're going to, test this out, this will have to be on. All right, and then if this is on your bench, have some other sort of box around here. So you've seen in the previous video how I had that other box. In the video before, I should say, that's in the surface mount version. You'll see how I had a box around here. This is designed to be poked inside of a chassis, right? And of course, this is completely insulated. Nothing is exposed. This is a non-contact style probe. Okay, so when it's in the chassis, it's shielded from everything, so you can very easily trace with this. All right, so that might be tricky for some. All right, but if it's out in the open here, it's going to listen to AC. Whatever is that way, this is going to listen to, and off to the side. You'll see that there's a little bit exposed here. This will listen to everything off to the side as well. So you'll notice in the other video, in the surface mount version, when I played that piano song and I touched the center conductor and I put my hand here, it picked it up. Well, if I put my hand here or here or here, you can hear the music. It'll pick it up right through my body, just like in that. So if you're new and you're just looking at this now, you can look at the surface mount version. It's almost identical to the way this one operates, minus the gain switch. Okay, so there you go. So what else can I tell you about this? There's a lot of things to go through here. So anyways, here again, this here attaches to the box. It has to be a shielded box. Now, since this is the probe, if you are uncomfortable with holding this, now keep in mind this is a non-contact style probe, so this is not supposed to be in any type of, touching any type of circuitry. This is insulated on the end and everything like that. If you're more comfortable, you can put this into another project box, a plastic one, and insulate this from yourself if you want. Again, this here will have to have a connection to a chassis in order to, of course, make the chassis ground, or that everything will hum, right? It has to be grounded to this. If you're uncomfortable with holding a metal box or a metal probe, you can put this into another plastic style box or something like that, or even wrap this in insulation or something like that. Don't use this in anything high voltage, again, right? And if you build this, you're doing this at your own risk. Okay, so be very, very careful. The probe shell for the other one is metal as well, and of course it's insulated on the tip. And the idea is to have this long enough so that if you're probing in anything, that this is away from it, so you're not going to touch any circuitry with this, right? So of course this requires the common sense as you're using this. The reason that I mounted this on the top like this is because it's like, if you look at like the Weller soldering guns and things like that, you know how they've got the tip on the top. It's just easier to see when you're using it if you're holding it like this, rather than having it in the center or on the bottom. That's why this is offset like this. Okay, you might be wondering that. Okay, so there you go. So that is that. Again, if you're uncomfortable with using something that is a metal probe that you're in contact with, because remember, this has to be in contact with a chassis or whatever you're working on, tied to negative, you need to insulate this or do whatever makes you feel comfortable. Or again, if you're just not comfortable using it, don't build it. What else can I tell you about this? Be very, very careful. Again, this is designed for low voltage troubleshooting. I don't want you poking this thing in anything that has any type of elevated voltages inside it. Again, it is insulated, but you need to be as careful as possible. And again, you're doing so at your own risk. Be very, very careful with this. Never, ever, ever tie this to an AA5 or AA6 chassis or anything like that. Ever. Because if you do, right, this is a metal probe, and AA5 and AA6s have a chance of having a hot chassis. All right, again, common sense needs to be used whenever you're building or putting together any type of test equipment. Okay, let's see here. What else can I tell you about the layout here? It's so simple to put together. You can drill this to whatever size hole you want. There are standoffs under this, so this is stood off the bottom here. I don't know if you can see that. Might have to brighten that up just a touch so that you can see that. So you can see how there are some spacers under here, right? That's standing this off, right? Because this is through hole, so you don't want the circuit board touching the bottom side of the box. And you'll notice that the BNC is not drilled in the center, it's drilled more towards the top side of the box. That's to make clearance for the board. So when this is all put together, everything is like, these wires are all soldered in, everything is all soldered in together, and then you put the board in and then you bend the wire over, soldered into the BNC. And this one here is you just press it into the center of the F connector. I think I've got one of those barrels over here I can show you. And again, if you want to just use, grab one of these. Again, if you just want to use the standard coax on the end and solder it in, you know, you can drill these 2 holes out, put this here, and then solder it on the bottom side of the board, put a loop with wire, you know, over the shield or anything like that. You can put the coax on either side. It doesn't really matter, right? You can put a loop through and solder it to the loop, and then put the center conductor through the hole on the upper side, or put it on the back side of the board like it's surface mount, and then solder it there and then run it up through this way. It's so versatile. So this is a standard F connector barrel, and as you can see in the center there, basically it just presses in, the wire presses in. So what I've done is I've mounted this on here like so, right? This is mounted on here like so. And that's a 3/8 hole, by the way. And what's really nice about this is the same nut that screws onto the BNC connector will thread onto this as well. They use the same thread, the same nut, they use everything. All these BNCs are kind of a standard thing. 3/8 hole, 3/8 hole here. You can drill this to whatever size of grommet and wire you have. And you can put this on here like so, and then just you take a wire with your pliers and you have to kind of give it a bit of force, and it goes pop, and it'll pop into the center. And there you go, it's done. And then of course you can thread whatever F connector, you know, piece of coax, whatever, onto the outside that you want. So that worked out very well. You know, I really like this build. That was pretty slick. I'm pretty happy about that. So you're going to see me using both of these in many of my future videos. I'll be using this and the surface mount version as well. They're both great to use. This one here just does not have a gain switch on it. And that's pretty much it. What else can I tell you? The polarity of the capacitors are marked on here. You can see a little plus here and a little plus, and there's a little plus by all the capacitors that are polarized. You'll notice that I used 0.1 microfarad for coupling caps just to make things easier. In the other one, it has 1 microfarad caps. 0.1, you know, you can get these poly style caps and whatever, and just put them in. You know, it's very versatile. A lot of the values that you see here are not specific. Okay, so you see 1.2K, 1.5K, 1K will be fine. Don't worry about it. 120 ohms, 100 ohms, 120 ohms, absolutely fine. Not a big deal. Don't worry about it. Let's see here. This here would trim the gain if you want to change these resistors. So there's 40 megs worth of resistance here. You could put a jumper in, put 20 if you want to take the gain down. I don't see why you would want to do that. The whole glory of this, you know, thing is it will hear, you know, the slightest amount of crackling in a capacitor or anything like that, or a resistor if it's intermittent. These can be interchanged if you want to put a 10 mic here and the 0.1 here, or vice versa. Absolutely fine. It doesn't matter. You can see they're both just basically, you know, this one here is they're in parallel, really, right? So not a big deal, either or. What else can I tell you? 50 ohms if you're running 50 ohm coax out. This would be 75 ohms if you're running some 75 ohm coax. If you don't know what impedance the coax is, 50 is fine. You can just use a 50 ohm resistor. So let's see. I was looking over this here, just seeing what else I can tell you. I think that's pretty much it. So it's very easy to build. The box and everything was mentioned in the previous video. If you're interested in this box, and a lot of information was in the previous video about this. So there's 2 docks in the previous video, and there'll be 2 docks in this video here that you can grab and put one of these together. Fantastic build. I really like this. It's so big and easy to put together, and again, just use parts out of your junk box. Stick with the transistors that, you know, I've suggested here if you want the same results that I'm getting. If you want to experiment with it, you know, by all means, go ahead. And, you know, just have fun. That's the whole idea of this, is have fun and build away. There you go. I hope you enjoy. And when this is all done, when the main box is all done, I will give examples of using this in circuitry, finding faults and everything. And you'll see how incredible this device is. And just so much more sensitive than the Super Probe. And with the detection unit that's going to be in there, it'll be great for sniffing out RF. It's going to be fantastic. I'm looking forward to getting that box released to all of you, and that will be coming very, very soon. All right, if you enjoyed the video, tap the heart symbol and leave me a comment below. I'll talk to all of you very, very soon. Take care. Bye for now.